right, IM3 classes. Today we're going to be solving polynomial functions by graphing. We've already had, we've spent a lot of time solving polynomial functions. So we have some algebraic methods to do it. First, we know how to find what the possible rational zeros or rational roots are. We test those using synthetic division. And then when we get down to a quadratic, we know how to solve quadratics by factoring. Or completing the square or the quadratic formula. So today we're going to find out the quickest way to do it if you have a graphing utility, either a graphing calculator or Desmos. Back when I was in school, we used to have to do this stuff by hand. We'd have to graph this by hand, and it was just tedious and didn't make sense to solve this by graphing by hand. It makes sense if you have something that can graph this for you. What we are going to use today to graph these things for us is Desmos. So you just go to desmos.com. Let me bring that up here. Use their graphing calculator function. And then you're just going to put in that function that we had. So it was 6x cubed plus 5x squared. So 6x, to put in powers, you got to click the keyboard button here. Here's a power button. So 6x cubed plus 5x, just push squared here, minus 17x minus 6. So to solve this by graphing, what you're going to do is find the zeros of the function. This is why solutions of the function are also called zeros. It's where the graph crosses the x-axis. These are the zeros of the solutions. On Desmos, you can just hover over it here, or if you click on it, it will put points in there for you. So our three solutions to this graph: -2, 0, that'd be -1/3, 0, 1.50, or that's 3/2. So here are the rational roots, rational zeros of this function, and that's all there is to it. So go to Desmos, plug in the function, and then click on the points where it crosses the x-axis. Those are the solutions to the graph. Let's go back to our PowerPoint here. So that is the function. So here, I'm not going to go back and put this function in there, but if we were to put that function into Desmos, this is what it looks like. Click on the points to find the zeros. So the solutions would be x equals -1.5, -1/3, that's -2/3. You can also just put in the decimals. That's fine too. Next thing we're going to be looking at is the finding local maximum and minimums, and then where the function is increasing, decreasing. So local maximums or minimums are the points where the graph changes direction. So it has this hump. So this is a max, this is a min. Notice it's not the absolute maximum or the absolute minimum, because this one doesn't have an absolute maximum. It just goes off into infinity. Same thing with here. So if it did have the very lowest point, that would be the absolute minimum. But the graphs we're looking at today, they're going to go off to infinity. So let's look at this first one: x cubed minus 3x squared plus 6. So we're going to identify all this stuff, the x-intercepts, the points where the local maximums and minimums occur, and determine the intervals for which the function is increasing and decreasing. If you plug it into Desmos, this is what it looks like. So we have, we'll just start off with the maximum. So here is the maximum, or the local max. I'm going to not write out the whole thing. So that's the local max. Here is the local min. All right. So to write that out, you can put in local. If you just put maxes, it's fine. Max is at 0.6. The minimum is at 2.2. X-intercepts, even write minimum, min, and then the x-intercept is at -1.1960. All right. So the local maximums determine the intervals for which each function is increasing or decreasing. So increasing, you can do this in go. So it is increasing. So you want to read the graph from left to right when you're determining if it's increasing or decreasing. So if you look here, it has a positive slope. It is increasing along this path here. So that is increasing where x is less than 0. So I'm going to actually use the book doesn't do it. I think it helps if we see that it is increasing from negative infinity to 0. All right. Then it's also increasing on this part here. So it has two increasing intervals. So it's going from 2 to positive infinity is increasing. And then where it is decreasing, if we look at where it is going down, see it's going down here, decreasing. So that is decreasing. That's from 0 to 2. So we're looking at the x coordinates when we're determining these variables or the intervals. So 0 to 2. And that's it. So you just got to identify those points, use Desmos, and then just look where it is increasing, decreasing. That is it for that. Yeah, we'll see you guys next time. I think we're moving on to logs. Not sure. I can't remember. We'll see you next time.